Welcome to Instructional Design of Good Manufacturing Practices in Industrial 5.0. I'm A.W. Schultz, and today we'll explore how GMPs are evolving in an increasingly automated smart factory environment. The concept of good manufacturing practices is undergoing a paradigm shift. In the age of Industry 5.0, GMP is not merely about maintaining quality standards. It's about proactively anticipating and addressing challenges, ensuring sustainability, and fostering innovation. Problem identification. As manufacturing facilities become increasingly automated, identifying potential safety hazards and ergonomic issues become important in creating a workplace that prioritizes human-centric values and employee protection, putting product quality at risk. Outdated monitoring systems have equipment malfunctions undetected and workers vulnerable to safety incidents, which problems often discover only after the incident occurs. Poor communication between human workers and automated systems leads to confusion, operational inefficiencies, safety hazards, and while outdated training programs fail to evolve with changing technological needs, compressing both workplace safety and production quality. To address this problem, supporting the smart factory begins with management and supervisor understanding the training. The training builds confidence and trust that follows a training that employees will have the skills and awareness to operate their complex machines and processes. Following an assessment, the training will be organized in 3 sections. The first section will be the overview training that will include interactive training that all employees will be required to attend. The topics will consist of personal protective equipment training, facility design and maintenance, documentation and record keeping, quality control, and equipment maintenance and collaboration. The training will be online with a classroom setting of 10 to 15 employees at the time and conclude with an interactive check for understanding with the trainer. The second section will be highlighted the technical knowledge of the machine and process. The training will be online classroom session with scenarios to check employees' responses. The final section will be completed while observing and operating equipment with the subject matter expert and trainer. The employees will be able to perform cycle their stop, start, power down correctly, lock out the equipment, and explain the correct maintenance practices for the needs assessment. As Morrison's discussed, industrial and organizational continuous seeking improvements and change in structural design and the instructional answers to the needs assessment. The same holds true in understanding the role and the needs in smart factories. A needs capability rates accuracy and employee feedback. In smart factories, the needs assessment of industrial design is critical for understanding the future and the critical incident needs, which are essential for developing an effective training program. Interviewing the workforce and observation will allow the understanding of employees' current needs and good manufacturing practices. Morrison's defines anticipated future needs as meaning of identifying changes that will occur. A smart factory leads face new technology and regulations to be greener with the evolution of Industrial 5.0. Understanding the future needs is critical. Smart factory leaders will allow each opportunity to design the training so that the employees are aware, knowledgeable, and able to support the change. Smart factory leaders should consider constructive incident needs as a second category. The critical incident needs to be referred to as fairly with significant consequences. GMPs are essential for preventing costly mistakes and quality issues resulting in product recalls, regulatory fines, or damaged customers' relationship. Adhering to GMPs also helps create a safer and a more efficient work environment where processes are clear and predictable. GMPs make everyone's job easier while ensuring the safety of both the workers and the product end user. In the context of smart manufacturing dealings with new and retaining employees, ensuring that employees understand the basics of health, safety, and the environmental is critical. GMPs are important to smart factories and Industrial 5.0 to prioritize making the employees feel safe. Learner analysis. Learning characteristics are important for understanding the type of supervisor or manager who needs to apply technologies in the workforce. The following from 6 assumptions and Malcolm Knowles' theory of anagoli illustrates the application of learning in smart factories. Adult learners need to understand why they learn something before understanding to learn it. In a smart factory context, employees need to know why the Industry 5.0 training is important and the roles and the company's future. They should understand how the training will help them adapt to new technologies, improve sustainability efforts, and enhance collaboration with machines. Supervisors should communicate the benefits of the training and how it relates to employees' job responsibility and factory goals. As adults mature, they move from dependence to self-directed learners, or self-concepts, according to Morrison. Smart factory employees likely have a self-concept responsibility for their decisions and lives. The training approach should support this by allowing employees autonomy in their learning process. For example, learning choices is how they complete certain parts of the training, or letting them set personal learning goals within the boundaries, training's objectives, and cater to the self-directed nature. Adults bring a wealth of experience in learning situations, according to Morrison. Many smart factory employees will have years of experience working with technology and factory processes. The training should acknowledge and build upon the experience, incorporating opportunities for employees to share their knowledge, discuss past experience with technological changes, and apply for the existing skills in new concepts will make the learning more relevant and engaging. The readiness to learn in adults becomes ready to learn when they sustain creates a need to know. In the context, the shift toward Industry 5.0 and the increasing focus on sustaining generate a readiness to learn among employees. They recognize adapting to these changes is critical for job security and professional growth. The training should capitalize on their readiness by clearly linking new concepts to the evolving demands of their roles in the smart factory. Adults are problem-centered rather than subject-centered in their orientation to learning, according to Morris. Smart factory employees will be most receptive to learning that helps them solve real-world problems they face in their work. The training should be designated around practical scenarios and challenges that encourage in the smart factory. For instance, using case studies of how industrial 4.0 principles can solve specific production or sustainability issues will appeal to the problem-centric orientation. While adults respond to external motivators, their most motivators are internal, according to Morris. Smart factory employees may be externally motivated by factors like job security and personal motivation. However, the internal motivations such as increased job satisfaction, personal growth, and pride in contributing to the sustainable efforts are likely strong learning drivers. The training should appeal to those motivators by emphasizing how their skills will enhance the personal and professional development and their ability to contribute meaningfully in the company's task analysis is an important part of instructional design, where the designer defines the concept required to solve the performance problems or elevate the performance as needed. Task analysis undergoes digital and connected equipment processes is important for optimizing workplace efficiencies and driving overall sustainability in smart factories entering Industry 5.0. Objectives. Morrison outlines objectives as fulfilling two key roles: helping the industrial design create sustainable instructional and offering a bias for assuming learning out. The objectives should be general to the use, but tailored to the specifics of the factory. While smart factories are massive and complex, the objectives need to be specific, and the sequence should follow a world or concept related to safety and quality within similar approaches in concurrent concept. Also, specifics are needed based on the nature of the smart factory's product. Instructional strategies. The foundation of effective manufacturing lies developing robust standard operating procedures, maintaining consistent quality control, and implementing control improvement methodologies that drive operational excellence. The success of manufacturing training initiates depends on establishing clear performance metrics, providing hands-on experience, and creating a culture of accountability where knowledge and transfer become integrated part of the daily operation. The following matrix offers a brief understanding of the context of performance and the perceptions of learnings that will achieve, as well as training with the administrator. The evolution of smart factories, Industry 5.0, demands a careful, structured approach to training and implementing good manufacturing practice. Through the Kemp model, Morrison can illustrate the needs assessment through learners' analysis based on pedagogy of principles and detailed task analysis. This instructional design framework provides a robust foundation for preparing the workforce for the challenges of human-centric automation. This three sections training approach, combining overall training, technical knowledge, and hands-on operation, addressing smart factories, corporations' theoretical and practical aspects, while ensuring the GMPs remain a priority for manufacturing excellence.